Hello students, good evening students. Today our topic is tautomerism. Tautomerism is one of the concept in structural isomerism, GOC part in the organic chemistry. It is one of the important topic both NEET and mains point of view. For NEET students as well as mains students, it is an important concept. Regularly from the tautomerism based question is asking in the NEET examination as well as mains examination. What is tautomerism? Look at the definition of the tautomerism first. Simple definition I am giving you. Tautomerism meaning one functional group is converts into another functional group by transfer of H plus ion from alpha carbon to functional group. So what is the definition here? Transfer of H plus ion from alpha carbon to functional group. What is alpha carbon? First of all, observe here alpha carbon. What is the structural requirement for tautomerism? Here, functional group carbon chain is present like this. At the end carbon, C double bond OH is present. What is the functional group here? This functional group is aldehyde. For suppose, carboxylic acid is present. C double bond OH. This is the functional group. Nitro group is present. To the carbon chain connected nitro group, N double bond O. This is the functional group. So functional group adjacent carbon is alpha carbon. Functional group adjacent carbon is alpha carbon. This is next carbon is beta carbon. Next carbon is gamma carbon. Functional group adjacent carbon is alpha carbon. Next carbon is beta carbon. Next carbon is gamma carbon. This is alpha carbon, beta carbon, gamma carbon. So based on the definition, students, I am giving the one structure. Observe here the what is the tautomerism we are observing now. This is the carbon chain. Here the C double bond OH is present. Alpha carbon having the 2 hydrogens. Next carbon having the 2 hydrogens. Here next carbon having 3 hydrogens. So tautomerism definition point of view, here this is alpha hydrogen. Alpha carbon connected hydrogen is alpha hydrogen. So here in this system, which is the more electronegative element? Oxygen is the more electronegative element. Here between carbon and oxygen, double bond is present. One is sigma bond, another one is pi bond. You know that already pi bond is a weak bond. So automatically the pi bonding electrons moving towards the more electronegative atom side. If it is moving on more electronegative element side towards oxygen, oxygen gets negative charge. Carbon gets positive charge. Automatically carbon and hydrogen, alpha carbon and alpha hydrogen, bonding electrons moving towards the carbon side. Why? Because this carbon gets positive charge. This carbon required which charge? Negative charge. So that's why this bonding electrons moving towards the carbon side. After shifting towards the carbon side, now observe here. See, oxygen gets which charge? Negative charge. The negatively charged oxygen attacked by H plus ion, OH. H between this carbon and this carbon, what is generating? Double bond is generating. Now here hydrogen, C, H2, here CH3 is present. So before this is aldehyde. Before hydrogen shifting, this is aldehyde. After shifting, here what is the functional group is present? Ol. What is the functional group is present? Ene. Ene plus ol. That is called as enol. So here aldehyde functional group is converting into enol. This is the tautomerism. For showing tautomerism, what is needed compulsory in the structure? Alpha hydrogen is needed. If alpha hydrogen is present, tautomerism is possible. So tautomerism meaning is one functional group is converting into another functional group by transfer of alpha hydrogen. This is tautomerism. Now applications we are discussing now. But what is the use of tautomerism? Why the tautomerism we are studying? What is the use? First of all, what is the use of the tautomerism? Tautomerism gives the which structure is the most stable structure. Which structure is the most stable structure? That means this structure is more stable or this structure is more stable. Another one, acidic strength of the hydrogen. Acidic strength. So which hydrogen, which alpha hydrogen is different molecules having different alpha hydrogens. Which alpha hydrogen is more acidic in nature? These are the applications in the tautomerism actually. Tautomerism gives the information of the stable form and acidic strength of the alpha hydrogen. What are the applications, students, in the tautomerism? Mostly the common applications. Which form is the most stable form? Keto form or enol form? Aldehyde form or enol form? Like that. And which alpha hydrogen is more acidic in nature? Different alpha hydrogens are present. Which alpha hydrogen is the more acidic in nature? Before going to these applications, first of all, we need to understand which structure is showing the tautomerism, which is not showing the tautomerism. That applications we are doing now. Now observe, students, here which molecule is showing the tautomerism, which molecule doesn't shows the tautomerism. I am giving the different examples. Here, this is the aldehyde. Adjacent carbon is the alpha carbon. This alpha carbon having two hydrogens. So this molecule shows tautomerism because of alpha hydrogen is available. Next molecule. This is a functional group. Adjacent carbon is alpha carbon. This side also alpha carbon is present. That alpha carbon having how many hydrogens? Here the three hydrogens are available. So this molecule also shows tautomerism. Next molecule. Here the next molecule. This is alpha carbon having the alpha hydrogens. Here also alpha hydrogens. This molecule also shows tautomerism. Next molecule. Here this carbon is connected with two methyls. This carbon also connected with two methyls. What is available here? Hydrogen is available. Here also hydrogen is available. This hydrogen is alpha hydrogen. So this molecule also shows tautomerism. Compulsory, what is required? Alpha hydrogen is required. Next molecule observed here. Functional group carbon. Adjacent carbon is the alpha carbon. That alpha carbon doesn't have the hydrogen. Reason? Methyl groups are connected. Three methyl groups are connected. This side also three methyl groups are connected. So due to absence of alpha hydrogen, this molecule not shows the tautomerism. Next observed here. This is cyclohexanone. This is alpha carbon. Here the alpha hydrogens are available. So this molecule shows tautomerism. Next molecule observed here. Here this is alpha carbon. Hydrogen is not available. Methyl groups are connected. So this is not showing the tautomerism. Next molecule observed here. This is alpha carbon. This is having the hydrogen. This is having hydrogens, three hydrogens. This is the methyl group having the three hydrogens. This is having the hydrogen, but this alpha carbon not showing the tautomerism. This is not showing even though it is having the alpha hydrogen. Reason that carbon is sp2 hybridized carbon. sp2 hybridized carbons not showing the tautomerism, but this one is showing the tautomerism. So it is possible. Next observed here the molecule. Here this is alpha carbon. So this molecule shows the tautomerism. Alpha hydrogens are available. Next, this molecule observed here. Here alpha hydrogen is available, but that alpha carbon doesn't shows the tautomerism. Alpha hydrogen is available, but doesn't shows the tautomerism. That because of sp2 hybridized carbon does not shows the tautomerism. In this, here only, not all the cases. Next here, hydrogen is available. That is alpha hydrogen. This is also shows the tautomerism. This molecule also shows tautomerism. Next, here alpha hydrogen. Alpha hydrogens are available, but what is the hybridization of this carbon? sp2 hybridized carbon. The system is connected with like this. That is doesn't shows the tautomerism. Next observed here. Alpha carbon, alpha carbon, alpha carbon, alpha carbon. Alpha hydrogens are available. So this molecule shows the tautomerism. Next, observe this molecule, alpha carbon. This is alpha carbon. Alpha hydrogens absent. Alpha hydrogens absent. Doesn't shows tautomerism. Next molecule observed here. Here the alpha carbon is present. Alpha hydrogens are available. This is shows tautomerism. Next here, this is sp2 hybridizer carbon. sp2 hybridizer carbon. Even though it is having the alpha hydrogen, this is doesn't shows the tautomerism. Next, this is shows the tautomerism. Don't confuse in this with these kind of structures. Reason that is already given enol form. This is already present in the enol form. So what is the keto form of this structure? Double bond O. So this is the enol form of this structure. This is keto form. So this molecule shows the tautomerism reverse. Next structure observed here. Alpha hydrogen is available. In this molecule, hydrogen is shifting not only from this one, hydrogen also possible to shifting from this carbon also. Here, this is conjugated system. To this conjugated system, this is alpha carbon, next carbon is beta carbon, next carbon is gamma carbon. At gamma carbon, hydrogen is present. That hydrogen is involved in the resonance, involved in the conjugation. So this hydrogen also possible to involve in the enol structure. So this molecule also possible to show tautomerism.